Okay, it's still the 21st of September, Monday, and we are talking about analyzing graphs. So one of the things that we want to be able to do is tell whether graphs are continuous or not. So if we look at this right here, a graph where you have to pick up your pencil to draw it. So here I draw this line, and then I pick up my pencil and draw that line. That's discontinuous. To be continuous, you have to be able to draw the whole picture without ever picking up your pencil. So this one, I draw this side of the picture, then I have to pick it up, draw this side of the picture. So this one has an asymptote. It's discontinuous. So to be continuous, we want to know where is it continuous, and we have to write the answer in set notation. Excuse me, in interval notation. So if we look at this, the interval where this is continuous is all real numbers. Remember, we're saying how wide is this graph? Where does this parabola start? Well, over here at -5? No. Or does it start at 2? No. Does it start at 5? No. Does it start at negative infinity? Yes. The parabola comes down here, and then it goes back. All right, we're saying how wide is the graph? What x numbers? That's where it's continuous. It's continuous over the entire domain. This next one, if you notice, has a hole in it, just like that one has a hole in it, right? So if there's a hole in the graph, it's not continuous. There's a point of discontinuity, and it's at 3. So this is continuous from negative infinity to 3, because this line goes this way forever, right? And it stops at 3. And then there's another line that starts on the other side of 3 and goes that way forever, right? So there's 2 places where this line is continuous. Same way with this one. If there's an asymptote, you're going to say, well, this left side, I can draw this whole left side without picking up my pencil, all right? So that's negative infinity to -2. There is no answer at -2 because it's an asymptote. There's no answer at an asymptote. And then on the other side of -2, so this would be like -1.999. On this side, over here, it's -2.11 or 2.001. So here we're going down forever. And this is from -2 to positive infinity. So I can draw this line forever to positive infinity. This line starts way over here at negative infinity and then comes up to 2. That's what we're talking about. Next thing, analyzing graphs. You have to know whether something's increasing or decreasing. So when increases, you always read from left to right. So increasing, this is going up from left to right. This is an increasing graph. This one is a decreasing graph because you're going, when you start on the left side, you go this way, you're going downhill. Okay? That's what this little thing says. This says when the x's get larger, the y values get larger. F of x means the y values. So when the x values get larger, like 1, 2, 3, 4, these x numbers are getting bigger, the y numbers are also getting bigger. 1, 2, 3. Right, that's what's happening here. This is larger. When the x gets bigger, the y gets bigger, the line's going uphill. Here, this one says when the x gets bigger, the y's get smaller. Oh no, that's what happens here. Because see here I'm going 1, 2, 3, 4. The x's are getting bigger, but the y values are getting smaller. Here I'm at 0, then I'm at -1, then I'm at -2, then I'm at -3. Right? So the x gets bigger and the y gets smaller. That's decreasing. So here they give you another example. It doesn't have to be straight lines. It can be curves, right? This one's still, when the x gets bigger, the y gets bigger. So this one's increasing. When the x gets bigger, because we're going this way, 1, 2, 3, 4, 5, 6. When the x gets bigger, the y is getting smaller. That's decreasing. And then constant is where it doesn't go up or down. So that makes sense. That's obvious. So when you're answering this question, you're telling me what x numbers can I pick so that the y goes up, or that the y goes down, or that the y stays constant. So here's an example. They give us a picture. They give us a picture that starts at -1. Looks like, actually this line starts way over here and comes down to +1, comma 2 looks like. So the interval where this thing is decreasing, because this is downhill, the interval where it's decreasing is from -infinity to 1, right? The interval where it's increasing is from 1 to 3, which is what that says. 1 to 3, the y values are increasing. That's what you're telling me. And then from 3 to infinity, the y values are constant. Totally doesn't change, doesn't go up or down, right? So when you write it, you have to write it in interval notation. That's what we are talking. It's decreasing on this interval, increasing on this interval, constant on that interval. That's how you'd write your answer. Okay. Symmetry with respect to the x-axis. Oops, did I skip a page? I think I did. Back one. There we go. Nope, I didn't. There we go. Yeah. Symmetric with respect to the y-axis, excuse me. That means that it's an even function. So if it's an even function, I've got, whenever I put a negative number into the problem, I get the same answers when I put a positive number in the problem. And the example is right here. If I have x squared, if I put 2 into the problem, I get the answer +4, because 2 squared is 4. If I put -2 in the problem, I still get the answer +4, because negative times negative is +4. The answer, whenever I put a negative number in, the y value when I put a negative number in is the same as the y value when I put a positive number in. That's what even functions are. Odd functions, here we go. Odd functions, that looks the same, but this says when I put a negative number in, the y value is the opposite of what happens when I put a positive number in. If I pick a negative x, the answer that comes out, the y value that comes out, is the opposite of what happens when I pick a positive x. So let me show you an example. Here is an example of an odd function. Right? This one, if I pick the number 2 and I put it in here, 2 to the 3rd power means 2 times 2 times 2, that's 8. And if I pick a negative number, like -2, negative times negative times negative, that would be -8. So see, when I pick a negative number, I get this answer, and this is the opposite of that. Right? That's what it says. When I pick a negative number, the answer is the opposite of when I pick the positive number. And that's exactly what happened. -8 is the opposite of +8. Okay. That's even and odd. What else do we need to know? You have to know how to graph square root functions, but you can type that in your calculator. Starts at 0, goes this way. Notice how they write the domain. The domain is from 0 with a bracket to infinity. Right? The range is the same way with a bracket, 0 to infinity. Here the domain is how wide is this graph? Well, it's forever wide, and it's forever tall. You say, no, it doesn't look tall. Well, every time you move over, it moves up. You move over, it moves up. It moves up really slowly, but if you were way over here at 1,000, it would be up higher than it is now. Right? And if you went to 1,000,000, it would be up higher then again. So that's the idea. Notice how they answer the question. It's increasing on the entire domain. See this one? and it's continuous on its entire domain, the domain and range. Whenever you analyze a graph, that's what you'll be able to do. Let's look at, did we miss one? Yeah, over here. Look at the domain of real numbers, right? And look, the parabola range is all real numbers. It only goes down to 0. There's any part of the graph down to the negative land. So range starts at 0, bracket, and goes up. Notice that it decreases on this interval because remember you start at negative infinity, you go to 0. What numbers can I pick so that the whole thing I'm driving down? Well, if I pick these x numbers, I'm driving downhill. And then for it to increase, I have to be going on the other side, 0. From 0 to positive infinity. Totally continuous. All right. I think that might be the thing you need to be able to do. Oh, you ought to be able to graph absolute value function. Absolute value function are decreasing on the left side, increasing on the right side. Right? That's what it says right here. Decreasing the parabola. Increasing the parabola. Continuous all the way. So that's how you write these answers for your working book. And I think we did this. So we'll do this again to show you one time that, whoops, see if it'll sit up there straight. Whenever you're dealing with this, you have to, oh man, I dropped the page. Silly boy. So I'm back over here. Ah, there we go. I knew it. All right. So this one's an odd function. How can I tell? Because whenever I pick a number over here on the left side, -2, the value is the opposite of when I pick +2. Right? This one's positive, this one's negative. This one's an even function. How do I know? Because when I pick a value like +1, it's way up here at 4. When I pick a value at -1, it's still up there at 4. They're the same exact value. When the y values are equal, it's an even. When the y values are opposite, it's an odd. And this one's neither. And you say, why? Because if I pick a number like 2, when I go to 2, it's way up here at 14. If I pick -2, it's not at -14, so it can't be odd. And it's not at +14, so it can't be even. They have to be the same to be even, and they have to be opposites to be odd. This is -2, 2, right? Well, that's not even or odd, so it's neither. All right, I think you're ready for today's homework. So let's just stop. Bye.